Hi, welcome back. We're going to now go over lesson 4.2 over polygons and congruence. So let's start with a little joke. A man came home from work and his birdcage was empty. What did he say? Polygon! Oh, all right. Enough with the bad math jokes. All right, so a polygon is a connected set of at least three segments in the same plane, and each segment intersects two others, one at each endpoint. All right, so we're going to go through these and decide whether or not they are a polygon. Again, you can refer back to the definition. The first one, it is a connected set of at least three segments. It's flat. It's in a plane. That's what it means. In the same plane, that means it has to be flat. Each segment intersects each other at the end points. So the first one fits every qualification. So yes. Is a figure a polygon? Yes. And my pen is still being glitchy. Okay. Now number 2. What do you guys think? Is this a polygon? Now it's flat. It only it doesn't really intersect anywhere like in the middle or anything, but there's one major problem with it. And it's this word here. We don't have segments. This is a circle. So even though many people think circles are polygons, they are not. So we're going to say this is not, so no. And the reason is doesn't have at least three segments. Doesn't have at least three segments. I hope all that appears eventually. Well, you heard me say it. It's trying to work. Oh, okay. Number 3. It has segments. Yes. They only intersect at the endpoints. Yes. There's at least 3 segments. Yes. But there is one major flaw here. What is the flaw? Are they all in the same plane? Is it a flat object? No, this isn't a polygon. This is a polyhedron. This is a 3-dimensional object. So, is this a polygon? No. Why? Because it's not in one plane. Not in one plane. Okay, number 4. Now, this is a tricky one. Because when you look at it, and if you only look at this part, that's a polygon. Or if you only look at this bottom part, that's a polygon. But when you look at it as a whole, it is not a polygon. So let's go through this. Is it a connected set of at least 3 segments? Check. Is it flat in one plane? Check. Now here's the catcher. Do they only intersect at the end points? No. It intersects right there in the middle, right? So that's a problem. So this is not a polygon. Actually, it's 2 polygons. But you can't just say this figure is 1 polygon. So no. Come on, pen. Doesn't. Actually, it does. Intersects not at the midpoint. Or not at the end point. Okay, next, number 5. Hopefully you can see right away what's wrong with it. It is flat. There are 3 segments, but this word right here, guys, the word connected. Are those sides connected? No, it's not connected. So no, it's not a polygon because the sides aren't connected. Oh, well, my computer is just doing dandy today. Well, we'll see if I can get it back. There it is. All right, the life of trying to teach online. Okay, so polygons are congruent if they have the same size and same shape. Now, we're going to pretend they're the same size and same shape, but they're just a reflection. So what we need to do is we need to learn what correspondence is. So correspondence means they match up. Okay, so like there are certain segments that are going to match up here. There are certain angles that are going to match up. So let's look at this and find the segment that corresponds to J. And I'm going to use an arrow for correspond. Hopefully you're saying J corresponds with A. So J corresponds with A. Now, these are points. Points don't have a size or shape, so we can't say the point is congruent. But what we can say is that the segment is congruent. So let's find another segment that connects with J. So I could either go with I or F. Let's do F. What does F correspond with? F corresponds with E. So I could say that JF is the same measure. In this chapter, the person that wrote your book actually starts using the word congruent. So congruent, you put the little, it's called a tilde. It's like a little squiggly thing on top. So JF is congruent to AE. Now on this problem, we could do this all day long. Find segments that match up or in the angles and show all of this. This would take forever. I'm going to show you something that's more relevant though. Let's do the definition of congruent figures. There must be a correspondence between their vertices such that all their corresponding sides and angles are equal. So that's kind of what we were doing in this problem up above. Now, I didn't do an angle, so I'm going to go back real quick and do an angle. So looking at this diagram, if I wanted an angle that corresponds and is congruent to angle B is congruent to what? Hopefully you're thinking to yourself, I. So B is congruent to angle I. Easy enough. What's congruent to angle A? Angle A is congruent to angle J. Okay, I just want to make sure I did everything that was in the definition. All right, corollary to the definition of congruent triangles. Two triangles are congruent to a third triangle, and they are congruent to each other. So this is like substitution property, but with triangles. So keep in mind, don't spaz out. You're not doing both today. I sure hope my pens holds up. All right. I'm going to try to draw this out if my pen will work. Okay, so I'm going to label these A, B, C, D, E, F, G, H, I. Okay, so the corollary says two triangles are congruent to a third triangle, then they are congruent to each other. So again, this is like substitution. So if I say triangle ABC is congruent to triangle DEF, and I say triangle DEF is congruent to triangle GHI, notice both triangles here, the first and the last, are both congruent to the middle triangle. Therefore, because remember the three dots mean therefore, we know that triangle ABC is really congruent to triangle GHI. All right, so as you can see, it's kind of like substitution because they both have DEF in common, and your final result is the first and the last triangle. Now, here's the best thing that you're going to learn today, because whenever you see this is called a congruency statement. Okay, write that down. I'm going to talk about them the entire chapter. Congruency statement. Here, I'll write it up here. Congruency statement. Now, this is the only thing that the person who wrote your book uses a congruent symbol for. It's when you're proving triangles are congruent to each other, which we will do with proofs this chapter. This is very important. The order of the letters matter. Okay? So when you see this, automatically, you know angle A corresponds with angle D. So let's go up here and look at this picture. Angle A and angle D are going to correspond. They're going to be the exact same measurement. And angle B and angle E are going to be this exact same measurement. So I'm going to put a different mark here. And we know C and F are the exact same measurement. So I'm going to put a different mark on them. Now, it doesn't know, it tells you that, but it also tells you things about segments. Look at the first two here, AB. It is congruent to the first two letters here, which is DE. Now, I should be writing this down. So let's do that. AB is congruent to DE. And the second two letters, BC, I don't know if that's going to look like a C or not, is congruent to EF. Now, where's the third set? You can look at the diagram and tell. A to C, so it's the first letter and the last letter. So order matters, so write that on your paper. Order of the letters matter. Hope you can read that, because I have to write it and then it appears like a minute later. AC is congruent to DF. Now, I didn't do the angles, so let's go back and do the angles. Angle A was congruent to angle D. Angle B was congruent to angle E. And angle C was congruent to angle F. There we go. So this is going to happen every time. Again, this is called a congruency statement. It tells you 6 pieces of information. So I'm going to make up one. Triangle. Now, sometimes I give you silly names to kind of throw you off. But it's okay. I was going to do boy, but do you know why boy wouldn't work? Because cow has an O and boy has an O. And that may not work out so well. Okay, let's do pig. P-I-G. So this tells you 6 things, right? So let's list the 3 congruent angles. C is congruent to, say it, P. Angle O is congruent to I. Angle W is congruent to G. All right, so that one's usually the easy one. The segments, for some reason, people can do 2. The third one, for some reason, is much more difficult. What's congruent to CO? Hopefully you're thinking PI. OW. What's congruent to OW? But IG. Now here's the last one, the tricky one. CW is congruent to PG. All right, so again, what is this called? This is called blank statement. What kind of statement? Congruency statement. It's proving the triangles are similar. Order matters. Tells you 6 things. All right, that's it for today. See you guys soon. Bye.